All right. Unit 5 test review number 1. If two angles of a triangle have measures of 58 and 71, find the measure of the third angle. Of course, you're just going to add up the two numbers you have. 129. What do you do with 129? Subtract it from 180. And some of you like to spoil it right off the bat. That gives you
51.
Oh, you're right, 51, my bad. Number 2. Determine if the set of segments can create a triangle. So remember, first of all, you want to make sure the three numbers are in numerical order from smallest to largest. And then you take the two small ones and you add them up. If they are bigger than the third number by itself, that is a triangle. Right? 4 and 7 is 11. Add those up, that's bigger than 10.
4 plus 6, it's equal to 10, so it's a triangle.
Well, the first part is right. 4 plus 6 is 10. But because it's equal and not bigger than 10, that is not a triangle. It must be bigger. It cannot be equal or less than. All right? Number 3, Kristen is designing a triangular ramp so she can practice jumps with her bike. She has 2 pieces of wood with measures of 6 and 8 feet. What is the range of measures of the third side? So really, it's just a word problem where you want to find out the third side. If you remember, if you're asked to find the range, your answer is generally going to look like this. X in the middle, less than's on both sides. How do you find the small number in the range? You subtract the two numbers, 8 minus 6. How do you find the large number in the range? You add them. And so the third side has to be bigger than 2, less than 14. Cannot equal those two numbers. The only bad thing about having the blinds open is now I have to see all the skippers out and about. Number 4, the figure below shows the positioning of a survey crew measuring the distance of a tree across the river. Which of the following best represents the measure of TAP? TAP is this angle right here. And for this part, there's actually more to it, or there's not as much to it as it may seem. If you look at the line that's going straight north and the line created by AP, those are perpendicular. And to confirm that, it's true over here. All right, there was no technical difficulties. This video just kept going without anything. But if you add those two, you clearly see you get 90 there. So all you got to do here is 90 minus 32.
Wait, is it 37?
58?
Wait, 37 plus 33?
No, on this side, 37 plus 53 makes 90. That's to show you it's a right angle. So it's true on the other side as well. Number 5, an isosceles triangle WXY. The interior angle W measures 100 degrees. Find the measure of the other two angles. In general, what do you know about an isosceles triangle? Well, yeah, you start with two sides usually with isosceles, but you should also know from that the two opposite angles are equal. So if this is 100, what do you know about the other two angles together? They're the same number, and in this case, they would have to equal 80. So basically what you're solving is 2x equals 80, which is simply 4. Oh, wait, that's not for that. Oops. Number 6, find the value of x. Three x plus 2x plus 70. What should they add up to? So minus 70 minus 70, 5x equals 110. Divide by 5. X equals 22. Heck yeah, they could. All right. Number 7, a student wants to inscribe a circle inside of a triangle. Which segment should the student construct to locate the in-center of the triangle? So they want a triangle with the circle inside. You know, that's done nicely. Which of our special segments will give us that and is where the in-center is formed from 3 of them?
Angle bisector.
Good job. Angle bisector. Number 8, consider triangle CDE. List the side orders by length from greatest to least. Not that you have to know the length, it's just how do the angles help you with that order. So first of all, we need to find angle C, which you can add 90 and 21.5 and subtract from 180. Or a little bit simpler version is, since this is already 90 degrees, if you just do 90 minus 21.5, you can do that. So let's see, that's going to be 8, 10, that's going to be 9, 10, 5, 8. So, what side of the triangle is the longest? Good. What's the second? And what's the smallest? Good. And if you're not sure where they're getting those from, remember, largest angle across from longest side, shortest angle across from smallest side. So 90 is your biggest angle. It's across from the CD. That's the first one. Next is the 68.5. That goes there. And D, being the smallest, is across from that. We've normally put them in order from smallest to greatest, but it doesn't matter. Greatest to least, you just flip the idea. J constructed a line segment from each vertex that was perpendicular to the line containing the opposite side of a triangle. At what point of concurrency did the segments meet? Which of your special segments goes from the vertex perpendicular to the line containing the opposite side? So the special segment is the altitude. What's the point of concurrency where they meet? Ortho center. And there's nothing special or no special property for the ortho center. That's why we don't really talk about it much. What is the altitude of triangle ABC, which is the median of BDC? So a couple things here. ABC is the big triangle. They want to know what segment is the altitude. What segment of the triangle is the altitude? B, D. Altitude again goes from the angle straight down to the opposite side perpendicular. The second part says what is the median, but not of the big triangle, of triangle BDC. Which is that? What does a median do?
Go from the vertex to the center of the midpoint.
Right, from an angle to the middle of the opposite side, or the midpoint. So that would be DF. And again, you know it's in the middle because those have the same lengths. Okay, so I don't know if y'all got this far or worked it out. It's an algebra problem, but once you solve it, you may realize that the numbers don't really make sense for the picture, but don't worry about it. Just use the numbers they give you. It's just one of those not drawn to scale. Those who made the problem didn't really think much about the numbers. But the idea, that's just weird when that turns off. That's an exterior angle. Our exterior angle theorem says it should equal the sum of the two what we call remote interiors, the two it's not next to of the triangle. So as an algebra problem, you should have x plus 50 equals 3x minus 10. When we kind of work through this algebra here, you get 2x minus 10 equals 50. You add 10, 2x equals 60. And of course, dividing by 2, x equals 30. Which doesn't look too bad there, except when you need to find HJI, 50 and 30 is 80. That would make this 100. And that doesn't really look like an obtuse angle. But again, we're just worried about solving it with the numbers they gave us, because that would make this 80 as well. Picture obviously not drawn to scale. The key here, knowing the exterior angle equals the sum of the other two. And that is all for page 1. Let's go to the back. Any questions from anywhere on the front? All right. All right, number 12, list the sides from shortest to longest. So again, like we did on the front, 65 and 70 is 135. 180 minus 135 is 45. So shortest side should be AB. Middle side should be good. And longest side will be AC. Not to be confused with AC/DC. They just want to rock and roll all night. No, wait, that's Kiss. List the angles from smallest to largest. Same idea, but with the angles having the side length. So shortest side is CB. That's across from angle A. Middle side is CA. That's across from angle B. And longest side is AB. That's across from C. ABC. It's as easy. Oh, wait, it is as easy. If two sides of a triangle are 7 and 12, what are the possible lengths for the third side? Also one we did on the front. X in the middle. Subtract the numbers to get the small value. Add the numbers to get the big one. X between 5 and 19. Which side is the shortest? Which side is the longest? So again, we got to find that third side. 60 and 58 is 118. 180 minus 118, 62. Given those three angle measures, what's the shortest side? Good. That's across from the 58. What does that make the longest side? AC. (16) Which angle is smaller, 1 or 2? Now, if you take the idea of longest angle across from longest side, shortest angle across from shorter side, you can apply it to this, and it's often called the hinge theorem. But if you notice, AB and DC are the same length. Okay, they got the dash. DB is the same length. So the two sides that make the angle are the same, but angle 2 is across from a side that's 38, and angle 1 is across from a side that is 43. So in the same idea, if the two sides are the same and you have to figure out the third, or the angle from the third, the longer the third side, the bigger the angle. So which one is across from the smaller side? Angle 2. So which of the two angles is smaller? Angle 2. Okay, that makes angle 1 bigger because it's across from the longer side. Where are we at? All right, let's kind of finish this up real quick. So same idea on number 17. Which angle is the smallest? Well, across from 5, your shortest side is A. Which angle is the biggest? Yeah, across from 15.5 is C. What are the possible values for x for the given triangle? So again, not drawn to scale, just looking for the range of values. 19 minus 5, 14, 5 plus 19, 24. And then it says complete with less than, greater than, or equal to for 19 and 20, which the numbers didn't seem to come along for the ride. But that's 19, that's 20. On this first picture, is angle 1 less than, greater than, or equal to angle 2? Right. And the reason you know that is 1 is across from 8, 2 is across from 7. Again, this side and this side are the same, as are that side and that side. So angle 1's across from the bigger side, it'll be larger. And then on number 20, FG and LM. They're both across from an angle that's 117. The two sides that make the angle are all congruent. What does that mean? Equal. Equal to each other. Any questions on the back side? All right, this answer key and the video will be up later on the classroom as usual. But again, the test will only be 12 questions, all multiple choice.
And we know most of this.
You should, yes. Mr. Rodriguez, signing off.